name is Dan Dye. I'm the Director of Professional Services at WeoGeo, and I want to talk to you today about the evolution of web mapping. In paleogeographic times, web servers rendered one map per page load. After panning or zooming, the entire page needed to refresh from the web server. This was known as the click and wait era. Better interactivity was available using Java applets and Flash, but click and wait was the standard for pure web applications like Esri's ArcIMS and MapQuest. As consumer GPS devices with navigation and MapQuest's driving directions brought GIS functionality like routing to the masses, there was a growing consumer demand for web mapping, and in response, Google acquired a couple of companies and rebranded and re-released their technologies as Google Maps and as Google Earth. Google Maps ended the click and wait era. The new asynchronous web technology, or AJAX, and the much hyped Web 2.0 brought on the era of neo-geography. Instead of rendering a single map for each user request, Google Maps were pre-rendered and cut up into 256 by 256 pixel tiles. With a slow internet connection, you could see these mapping tiles filling the iframe like squares on a chessboard. With a fat pipe, tiles both inside and outside the map frame preloaded and continued to preload as the user panned the map by clicking and dragging. This seamless panning experience became known as the Slippy Map. There are two dominant spatial reference systems used by Slippy Maps. Our old friend, the World Geodetic Reference System, aka lat long WGS84, or known to the geognoscenti as EPSG 4326. To the dismay of paleogeographers, the more popular spatial reference system is WebMercator. It assumes a spherical Earth and can't display north or south of 85.05 degrees latitude. Its original EPSG code spelled out Google in leet speak. At zoom level 0, World Geodetic renders the whole Earth with 2 tiles, and WebMercator uses 1. Each subsequent zoom level has 4 times as many tiles, so zoom level 1 has 8 in Geodetic and 4 in Mercator. Look at how quickly these numbers become outrageously large. At zoom level 16, WebMercator requires 4.3 billion tiles to render the whole Earth. The zoom controls in Google Maps only allow zooming to level 19, which requires nearly 550 or 275 billion tiles to cover the Earth. However, each Google tile has a unique URI and can be requested directly. Using this approach, tiles can be requested all the way to zoom level 22. This would require 17.6 trillion tiles. So to host a Slippy map, you either need to use Google Maps or pre-render all of those tiles yourself, right? WeoGeo doesn't use Google tiles, and we do render our own. Our entire operation is hosted on Amazon Web Services, and I've described in other conferences scaling hundreds of elastic computing cloud instances to render map tiles, but we don't host 1 trillion tiles. Geographers know that areas of interest are not evenly spatially distributed. Microsoft researchers published a paper on this topic. They analyzed logs from virtual Earth and visualized the results in HotMap. You can see that users are interested in urban areas, major highways, coastal areas. Not surprisingly, users have very little interest in viewing 1 to 1,000 map scale tiles in the middle of the Gulf of Mexico. Those areas are boring. So instead of pre-rendering 17.6 trillion tiles, half of which would be insufferably boring, we want to pre-render the interesting areas only and fall back to rendering the boring tiles only if they're requested. For even better performance, we can have 3 tiers. Tiles in a content delivery network like Akamai, tiles pre-rendered but served from a static web server, and failing that, tiles rendered on WeoGeo's stack for this model involves Amazon CloudFront as the CDN, Amazon Simple Storage Service for static tiles, and an Elastic Computing Cloud instance running Mapnik to render the tiles that haven't already been pre-rendered. In addition to the open source stack, our data sources are also all free. We use OpenStreetMap, US Census Tiger data, and Natural Earth data. These are stored in shapefiles and in PostGIS databases on the rendering instances. Using free data sources, free software, and pay-as-you-go cloud computing, you can roll your own world-class Slippy map tiles and rival performance of Google Maps. Come to the roundtable session tomorrow on web mapping at WhereCamp to talk more about these data, tools, and workflows. Thank you.